Hi. In this lecture, we're going to compare and contrast the three ways we've thought about modeling people. So remember we talked about first people being rational, people having objective functions and optimizing with respect to their objectives. Then we talked about how that's somewhat unrealistic. We talked about behavioral models. And I said you can think of these as either sort of rationality plus, where we sort of assume rational behavior but we add in a bias, or rationality minus, as sort of being just a little bit below rational behavior. And then the third thing we did is we said, well, maybe we could even go simpler and we could just assume that people follow rules. These could be fixed rules, they could be adaptive rules, and when we write down a model, we could just say, here's the rule that people follow. Now, in some cases, the rule that people follow will be rational. In some cases, the rule that people follow will be behavioral. In other cases, the rule that people follow will just be some rule that we made up. What we want to do in this lecture is we want to ask, does it matter? Does it matter which rules we write down? Does it matter whether we have rule-based behavior, optimizing behavior, or behavioral models? Well, the answer is it depends. And one of the reasons why we model is to figure out how much does it matter how effectively we model, or how accurately we model, I should say. So let me do two examples. First, I'm going to talk about a market, just a pure exchange market, and then I'm going to talk about a game called Race to the Bottom. And we're going to see in the market, it really doesn't matter that much how we model behavior, but in the race to the bottom, we're going to see it matters a lot. So let's get started. So two-sided market. What is a two-sided market? Well, two-sided market has a group of buyers, and these are people who want to buy some good. And let's suppose, just for the sake of argument, that these buyers in this setting have prices between $0 and $100. That means they're willing to pay somewhere between $0 and $100 for this good. Now, in addition to the buyers, there's some sellers, and let's suppose the sellers are willing to sell for between $50 and $150. So now let's think about what would rational people do? Suppose people were completely rational in this setting. How would they behave? Well, if you're a buyer, you'd basically bid a little bit less, right, than your true value because you'd try and make a little bit of money. And if you're a seller, you'd probably ask for a little bit more than your true value. And how much more or less you ask for is going to depend on, what the distributions of these buyers and sellers are. So if you're fully informed about what these distributions are, you're going to shade in particular ways. Now what's going to happen is, let's suppose that people keep calling out prices. We'll just assume that people call out prices until the market clears, until the number of goods sold is exactly equal to the people want to sell at that price is exactly equal to the number of goods that are bought. So the way it's going to work is each buyer calls out a price they're willing to buy at, each seller calls out a price they're willing to sell at, and then we pick some sort of price in the middle so that we get an even number of buyers and sellers. Well, what's going to happen in this situation is that the only buyers that are going to have a value of at least 50, since people are rational, the only buyers that are going to actually be able to buy anything are those that have values above 50. So the relevant buyers are going to have values in 50 to 100. So we only need to worry about these people. So we can call these B star. And the relevant sellers are going to be the only ones that have values between 50 and 100 as well, because the ones that have values above 100, or from 100 to 150, they want too much. Nobody's willing to pay that much for their goods. So what's happening is people are going to call out these prices, and what we're probably going to get is we're probably going to get a price of around 75, right? Where some of the buyers buy, some of the sellers sell, but not all of them do. Let's suppose instead we assume people are biased, that they're not super strategic, and they didn't figure out exactly how much to shade their bids. Well, then what people would probably do is they might rely on sort of focal bids. So people will be more likely to bid 50 or 60 or 70 or 75, even increments. So let me be more specific. So it might be that if you're a rational buyer and your value was 56, that what you should do is you should say, I'm willing to pay 53.72 cents, right? You solve some really fancy mathematical equation and figure out that's exactly your optimal bid. Well, a behavioral person might not do all that math, and that might say, well, my value is 56, so I'll bid 52, or I'll bid 50, 55, right? Just some focal number. They're not going to do all the math. Well, again, if there's just those slight deviations, you're still probably going to see a price of about $75. So optimizing behavior and sort of slight behavioral bias is not going to be a big difference. What about rule-based behavior? Well, this has actually been studied using a simple rule-based behavior called zero intelligent agents. This is ZI, we'll abbreviate it. So zero intelligence agents work as follows. If you're a bidder, what you do is you just sort of, if you're a buyer, what you do is you just basically say, okay, I'm just going to pick some random amount less than my value. And if you're a seller, you just pick some random amount more than your value. So if you're a buyer and your value is 40, right? So if I'm a buyer whose value is 40, I might say, oh, I'm willing to buy it for 20. And if I'm a seller whose value is 60, I might say, oh, I'm willing to sell it for 63. So what happens is you just choose some random amount. Well, it turns out if you analyze this sort of market with these zero intelligent traders, what you end up getting is something with a price pretty close to 75 and not that different from what you get with rational actors. So in a two-sided market, right, and things, we've got models in economics where we've got sort of supply and demand curves and things like that, right, and we get some price. It turns out the market itself has so much influence, the institution itself has so much influence, the behavior really doesn't matter a great deal within some fairly wide range of bounds. So in markets, we don't care as much about modeling behavior. But now in games, we do. So let's do a specific game called the Race to the Bottom game. And here's how it works. You pick a number between 0 and 100. There's a group of people in a room. Each person's going to pick a number between 0 and 100. Whoever's closest to 2/3 of the mean wins. Right? So what do you do? Here's a little quiz. What do you do in this situation? Well, let's look. So what does a rational person do? So what a rational person is going to do in this situation, it turns out, is bid 0. But why is that? Well, it's a completely symmetric game, right? So everybody's got the exact same incentive. So if everybody's rational, everybody should be doing the same thing. So suppose everybody was picking 6. If everybody was picking 6, then the mean would be 6. But if the mean is 6, 2/3 of 6 is 4. So if you're rational and you know everybody was picking 6, you should pick 2/3 of 6, so you should pick 4. So, but then everybody should pick 4. But if everybody's picking 4, then you should guess 2/3 of 4, right? Which is 8/3. But so should everybody else. So if everybody's picking 8/3, then you should guess 2/3 of 8/3, and so on and so on and so on, until eventually you get down to everybody should be bidding 0. So that's what rational behavior would be. What would biased behavior be? Well, if you were sort of not strategic at all and super biased in the situation, you say, okay, picking a number between 0 and 100, I don't know, this 2/3 of the mean thing, I'm confused. What I'm going to do, I'm just going to guess 50. And in fact, if you watch people play this game, there's a certain percentage of people who do guess 50. And in fact, I've done this in my classroom a whole bunch of times, and you'll get a significant percentage of people who just say, I'm going to guess 50. Now, what would a behavioral rule be in this situation? What would a rule-based behavior be? Well, again, this is again that's been studied a lot. And a rule that people tend to follow is this. They say, well, people should guess 50. But if everybody guesses 50, I should guess 2/3 of 50. So therefore, I should guess 33. So you see a lot of people guess 33. But then there's a lot of other people who say, well, everybody should guess 33. So if everybody's going to guess 33, I should guess 2/3 of 33, which is 22. And so if you look at real experiments, you see some 50s, some 33s, some 22s, and some, right, 2/3 of 22 is 14. So you see some people actually say this, look, people should guess 50. So since they should guess 50, I should guess 2/3 of 50, which is 33. Then they say, but everybody should guess 33, so then I should guess 2/3 of 33, which is 22. But then everybody's going to guess 22, so I should guess 2/3 of 22, which is 14. Now, of course, if we kept going with this, we get to the rational behavior eventually, which is 0, right? And in fact, if you play this long enough, these numbers do creep down towards 0, but they typically don't get there. You have to run it a lot of times. So what's interesting here is the behavior we see is this rule is sort of a mix of rational and bias, right? A bias thing is to guess 50. So people sort of start out with this base rate bias of 50 because it's in the middle. After that, they start sort of best responding. Remember, one of our adaptive rules for learning was to best respond. So the best response if everybody chooses 50 is to choose 33, and the best response if everybody's choosing 33 is to choose 22, and so on. So what we see is the rules that people use are sort of start out with a flavor of bias, and then they become somewhat rational. Let's do something really fun here. So let's suppose we have 2 rational people in this game and 1 irrational person. So let's suppose you're sitting in the place with 3 people, and you're a rational person, let's say. You've seen this game before, you know how it works. And you're playing with me, and I've seen this game before, I know how it works. But then there's this third person sitting in the room, and this third person we don't know anything about. We know that they haven't seen the game before, and they hear the instructions, and we're both looking at them trying to figure out, what is this person going to do? Well, let's try and analyze this. So suppose I'm a rational person, and you're a rational person, so we're going to pick some amount R, right? Now, the other person, this irrational person, we've got to make some decision, like, what do we think they're going to pick? Well, suppose we both think they're going to pick X. Well, if they're going to pick X, we have to decide how much do we pick. What do we pick? Well, here's what has to be true. The amount we pick, R, has to be 2/3 of R plus X, right? Because it's got to be 2/3 of the sum of everybody else's divided by 3. So it's got to be 2/3 of the mean. So it's got to be 2/3 of R plus X divided by 3. So if I multiply this out, I'm going to get 9R has got to equal 2 times R plus X, right? And so then I'm going to get, ends up being 4R, so I'm going to get 5R equals 2X. So R equals 2X over 5. So what that means is, if we both think, oh, this other person is what? I don't know, totally irrational. Suppose we think the other person is going to choose 50. If we think the other person is going to choose 50, then R equals 2 times 50 over 5. R is going to equal 20, right? So if the other person chooses 50 and we both choose 20, the sum will be 90, right? So the average is 30, and so 2/3 of the mean will be 20. So why did I do this example? Let's think back. If everybody is rational, the mean is 0. The mean bid is 0, and 2/3 of the mean is 0, and we split the money. But here, if we throw in one irrational person, then we no longer get 0, right? We get something a lot bigger than 0, because the rational people have to take into account what the other person's bid is going to be, and so they want to make their bid as a function of that, and that drives up their bid, which drives up the mean, which in turn drives up their bid. So what's the lesson we take away? Well, I think the simple lesson is this, is that rational behavior is a really good benchmark, but it's also important to include biases in our model. Think about, are there biases that would be relevant? And it's also really important to think about, what if we just write down a simple rule? And then if we compare these three things, rational behavior, bias, right, and then simple rule, and we see sort of, well, how much difference do we see in the outcome? If the difference is small, then we can say, okay, look, our result seems to be sort of invariant to behavior. If the difference is big, then what we've got to do is we've got to sit back and think, okay, which one of these three makes the most sense? And regardless of why we're modeling, whether it's to just be a more intelligent citizen of the world, whether it's to use and understand data, right, whether it's to just get the logic right, or whether it's to design something or strategize in some way, it's probably really useful to think about all three classes of models in the context that you're considering. Thank you.